In this lesson, we're going to talk about vectors, what they are, how to represent them, and how we use them in math to solve problems. A vector is a movement of something in a particular direction. That movement has a length and a direction and can be represented either as a column vector or as a line with an arrow. A column vector is a method to show how to move on a grid from one coordinate to another coordinate. It's written as two numbers within brackets, one above the other. The number on the top represents the horizontal movement or movement in the x direction, and the number at the bottom represents the vertical movement or the y-axis direction. When the top number is a positive number, we move to the right, and when it's a negative number, we move to the left. This is similar to how graphs normally work, with the positive values on the right and the negative values on the left. In a similar way, when the bottom number is positive, we move up, and when it's negative, we move down. The combined movement of any point from one coordinate to another coordinate is the combined movement of the two directions in the column vector. As an example, the column vector shown means we move 3 blocks to the right, then 2 blocks down from our original point. We can draw a straight line with an arrow to represent the movement from our original point to the new point. This line drawn is the same vector as the column vector, and we can represent this vector in either of these two ways. Additionally, we can represent a vector in two further ways. First as a bold letter, or combination of bold letters, such as an A or a B plus 2C, depending on the information given, or as two letters with an arrow above them to signify the start and finish of the vector in that order. Since a vector is only determined by its length and direction, vectors that have the same length and direction but start from different points on a grid are considered the same vector. In other words, no matter where we place a particular vector on a grid, it remains the same. Vectors have special properties that allow us to do vector arithmetic on them. If we multiply a column vector by any number, we multiply both of the numbers inside the brackets by that multiplier outside the bracket. The effect this has on our line vector will be to extend our line by the same multiple in the same direction as the original vector. Therefore, the length of the line changes by the multiple, but the direction the line travels in remains the same. We can also add and subtract column vectors to produce new vectors. When we add two or more vectors together, we do simple arithmetic on the top numbers together, then do the same on the bottom numbers. The resulting values will be a new vector that represents the addition of the previous vectors. A simple example should help us. Assume we wish to add the column vectors 3, 4, and 5 minus 2. We place them next to each other with our addition sign and add the top to get 8, then add the bottom to get 2. Our new vector is therefore the vector 8, 2. If there were 3 or more vectors, we would simply have more vectors in the addition. We can also add and subtract line vectors, but how we do it is not as easy as the column vectors. When adding 2 or more vectors that are line vectors, we can only achieve a result if we place the vectors on the grid in a specific way. Remember, a vector can be placed anywhere on a grid as long as the length and direction remain the same. When adding vectors, we need to place the vectors in such a way that the beginning of one vector is placed at the end of another vector. The illustration should help us understand how we do this. We have 2 line vectors and wish to add them together. We move one of the vectors and place it in such a way that it is at the end of the other vector. The result of adding these two vectors is a new vector drawn from the start of the first vector to the end of the second vector. Notice that the two vectors that were added together form a continuous path from start to finish. This is the key to adding line vectors. No matter what directions the vectors are going in, there must be a continuous path from the start to the finish. I hope this has been helpful, and thanks for watching.